Hello everyone. Today we are going to start our chapter 2. And our chapter 2 is motion in one dimension, that is 1D. So in this chapter we will learn about all the objects moving in one dimension. Now the first thing, it can make you confused that what is this term dimension mean? Now, the term dimension refers to the minimum number of axes or coordinates you require to explain something. It refers to minimum number of coordinates required. Clear? We know that we have three coordinates x, y, z, and in terms of quantities we can express as length, breadth, height. But all quantities does not have these three. Just for an example, if I am thinking about a very, very thin object like a hair, it only has length. Only length is present, but width, no, width, height, both are negligible. Width and height both are very negligible. So what do we require? We require only length to express the quantity here. So see, it has only one dimension. It has only one dimension, that is here. Similarly, if I am looking at a square, clear? Any kind of square or rectangle, whatever you take, it has only two sides, length and breadth. But does it have any height? Answer is no. No cause of height. So how many coordinates I am requiring? Two. One is length, another is breadth. So I require two coordinates to express a square or a rectangle or a parallelogram or a rhombus. So these kind of quantities require only two coordinates, length and breadth. So these quantities will be called two-dimensional. These quantities will be called 2D, that is two-dimensional figures. And furthermore, if I just think about the cube or cuboid, say if you have a cube or cuboid, so they have all three coordinates. They have length, they have breadth, also they have height. So length, breadth, height, all these three quantities are required for a cube or a cuboid. So such quantities which require all three coordinates to express, that is length, breadth, height, this kind of quantities will be called three-dimensional 3D quantities. Clear? These are called 3D or three-dimensional. So we have seen that the quantities which require only length, that is only one axis, only x-axis, they are all 1D. And those who are requiring two, length and breadth, like rectangles, these kind of quantities are 2D, and cuboid, all these three quantities are required in these cases, they are called 3D. So in our chapter we will only think about 1D quantities, because our chapter is on one dimension. And motion in one dimension means motion in only one direction at a time. One direction at a time. Clear? As they have no second or third direction, so they were focused to move in a single straight direction. Clear? This is the idea of dimensions that was I want to tell all of you. After you learn about dimension, next thing is that we have to classify into the states of matter. No, this is not the states of matter like solid, liquid, gas. No, they are kinematic states. Means here states can be classified into two. An object kinematically can be in any two states out of the following. Either they can be in rest or they can be in motion. You know, if you look around the things, you will see some objects are not moving from their place. You call that those objects are at rest, and some objects are moving. Clear? That objects are known to be in motion. Clear? Now, if we just look at these things, we need to define that if I ask you what is rest and what is motion, how will you define these two quantities? Let's see. The first quantity is rest. Now, question appears, what do you mean by rest? Now, if an object does not move from its place, if an object does not move from its place, with respect to time, then it is at rest. I hope this is clear. So that means if an object is not moving from its place with time, clear? Means you have a watch in your hand, just look around. Just look at your computer or your mobile phone. That objects are not changing their places with time. Are they? The answer is no. Wherever they are present just 5 minutes before, they are still at present there. But you just come out of your home and see the cars moving on the street, you will find out that in each second they are changing their position. So, if an object does not move from its place with respect to time, then it is said to be at rest. Clear? This is the definition of rest. And similarly, you can also define motion. I think it is very clear to all of you already that if I ask you what is motion, how will you define them? The answer is very simple, that if an object changes its position with time, if an object changes its position with time, then it's a comma, then the object is in motion. Clear? Then the object is in motion. That means to be in motion, you must need to move from your places with time. Without moving from your place, it cannot be said to be in motion. Clear? So we got two states of an object. Those are state of rest and state of motion. Now our chapter is on the topic of motion in dimension. So previously we have learned what is dimension. Now we will learn about the motion in that dimension. Now if an object starts from point A, and if it is in motion, then it is bound to move from its location like this in any of the directions. And after it starts moving like this, what will happen? After a certain time, it will reach at some place. I can say the object from A has now reached a point B. If an object is in motion, it is moving from one place to another. And in the beginning it was at point A, and in the end it is at point B. So if an object is in motion, we need to know some new quantities about them. Such quantities, I can list them up like distance, displacement, speed, velocity, acceleration, force, and so on. In this chapter, we will learn about them. But before we learn about these quantities, first I want to tell you about some characteristics of these quantities. About the characteristics of these quantities. That these quantities, which are all looking like same, they are all quantities, speed, velocity, acceleration, force, but are they very similar to each other? Are they very similar to each other? That is my question. That these quantities actually may look same, that all are quantities which are related to motion, but all these quantities are not same. Why not same? Now they have different characteristics, and according to their characteristics we can classify these physical quantities into two types. These physical quantities can be classified into two types. I hope some of you can guess the names because it was already little bit done in class 7. Anyone? Yes, a lot of you have guessed it right. They can be classified into two. One is a scalar quantity. The one is a scalar quantity and another is a vector quantity. Clear? In these two types, it can be classified. Okay. So first we need to know on what is scalar and what is vector. Now just say, first I am talking about scalars. Now, in all the time, if you know that each and every quantity has some magnitude and some direction connected to them, but all these quantities does not require that. What are scalar quantities? Now the quantities which have only magnitude. Magnitude means value. Just like 5 kilometer, 10 meter, like this magnitude, the value has only magnitude but no direction. Such quantities are called, scalar quantities. Clear? So there are a set of quantities which requires only to learn about their magnitudes, their values. That can be 5, that can be 10, but we only require the value, but we don't need to know any about their direction. Such quantities are called scalar quantities. I am giving you some example later. First, I am going to tell you the two definitions of scalar I have told. Now I will tell you the definition of vector. Next is a vector quantity. Which quantities are called vectors? Now the quantities is quite clear. The quantities which have both magnitude and direction. Which have both magnitude and direction. Clear? Both magnitude and direction, they are called vectors. They are called vectors, vector quantities. Clear? Now I am giving some examples on them. Just like if I ask you one question, how much work did you do today? I just ask you how much work you did today. You can tell me, sir, I have done 20 joule, some will say, sir, 50 joule. Will I ask you in which direction? Will I ask you that in which direction? No, nobody asks. If someone asks you how much work did you do, you usually say, if you are asking a physics question, that 20 joule, 50 joule, 100 joule, this amount. Nobody asks you in which direction the work is done because that is not important. The question how much work, the only answer is 20, 50, this amount. So you can see the question of work can be answered easily only with values, only with magnitudes. They don't require directions. Clear? So this kind of quantities like work, some other quantities are one we got here, work. Next will be distance. Just ask you the distance of a place. You always answer 5 kilometer, 10 kilometer. You don't say in these angles, this directions. The distance means a quantity. Speed, but not velocity. I'm warning you. So these kind of quantities only require magnitudes. So they are examples of scalar quantities. Again, there are some quantities like force. I ask you how much force? You tell me 5 Newton, 10 Newton. The question must be asked in which direction the force is working. In which direction the force is working. Because if we don't know the direction of the force, we cannot understand in which direction things will work. So in case of force, along with the value 5, 10, we don't need the value, but we also need the direction, in which angle, which direction. So such quantities are example of vector quantities. Such quantities are example of vector quantities. Apart from force, I have mentioned now, vector quantities are force, pressure, velocity, not speed, displacement. Clear? These quantities are example of vector quantities. Clear? So we learned about these things today. We learn about the motion, rest. We learn about dimensions. We learn about the scalars. We learn about the vectors. Their examples. How are they different from each other? So I'm asking all of you to read the chapter. Ask me if there are any doubts. Clear? So thank you. Use your Selena book as reference and keep on studying. Thank you, class.